Let's start our discussion. Am I audible? শোনা যাচ্ছে? আচ্ছা, রাহুল দাস আছো নাকি এখানে? রাহুল দাস
স্যার আছি।
রাহুল আমাকে একটা জাস্ট হোয়াটসঅ্যাপ করেছিল যে আমি যে পোর্টের লিস্টটা দিয়েছি আমি পরে দেখাবো, সেখানে খুব ভালো অবজার্ভ করেছে যে পোর্ট এবিসিডি এফ জি এইচ আই জে কে এরকম আছে। এর মধ্যে আমি বলেছিলাম যে 11 নাম্বার অফ পোর্টস, কিন্তু আর্কিটেকচারে দেখা যাচ্ছে যে পোর্ট আইটা নেই। হ্যাঁ, পোর্ট এল আছে কিন্তু আই নেই। আবার আমি এখানে ফলে ওটা কি হবে যে আই শুড বি রিপ্লেসড বাই এল অ্যাকচুয়ালি। আমি যেটা করিয়েছি, পোর্ট আই বলে কিছু নেই, পোর্ট এল আছে। টোটাল নাম্বার অফ পোর্ট সেম। ঠিক আছে, আমি জাস্ট টাইপ করতে গিয়ে বোধহয় প্লেন না দেখে পড়ে গেছি তোমাকে। থ্যাংক ইউ ফর ইউর অবজারভেশন। ইনফ্যাক্ট আমরা পোর্ট এলটা ইউজও করেছি, আমি পরে দেখাবো সেটা। সেটা হয়তো আজকেই আমরা দেখবো আর কি। Okay, so that is the modification, that port I will be replaced by port L in our list of 11 number of ports. Thank you, Rahul. Let's start our discussion. Now today we will write our program on timer counter, just a very small discussions that we completed in our last class. That is architecture of timer counter. Now in timer operation, it keeps track of time, so the rate of increment is always fixed. It is driven by an oscillator system clock or oscillator clock, and a prescaler is also there, that is there. So when our timer counter select multiplexer selects the timer operation, then our timer will be selected. Okay, and the input clock, timer clock, will be passing through the multiplexer, and our timer for overflow timer it will be TOV flag will be 1, and for compare match our count value, which is already stored in TCNT, at every rising or falling edge of the timer clock, that count value will be compared with the OCR content, output compare register content. When they are equal, after comparison OCF flag will be 1. So that is our timer operation. Now when our timer counters select multiplexer is activating the counter operation, then our input pulse, externally applied input pulse or event driven pulse, I told you event driven pulse will pass through the edge detector. It will sense the rising edge or falling edge. Okay, and that edge will pass through the multiplexer and it will be a counter operation. Okay, and either TOV flag will be 1 in the normal mode, or the OCF flag will be 1 in the compare match mode. And all such things, the mode of the timer or counter, whether it will be acting as a timer or counter at all, what will be the value of the prescaler in counter operation, what will be the edge, type of edge, rising edge or falling edge, which will be detected. All such finer details will be controlled from the content of a control register called TCCR, timer counter control register. So that is the essence of the architecture of timer counter hardware inside our AVR microcontroller. I discussed it in our last class. Let's see the timer operation. Okay, in timer operation, actually, I told you that there are two types of timers: 8-bit timers and 16-bit timers. 8-bit timer is timer 0 and timer 2, and other timers are 16-bit timers, timer 1, 3, 4, 5. For 8-bit timer, there are two control registers, and for 16-bit timer, there are three control registers for each of the timer. For count register also, that will store the count value at every rising or falling edge of the timer clock. That will be stored in the 8-bit count register, TCNT 0 or TCNT 2 for 8-bit timer. But for 16-bit timer, there are two registers. One is one will be storing the higher byte of count value, that is the TCNT H, and TCNT L will store the lower byte of count value. So there are two sets of registers for each of the 16-bit timers. Okay, so this is the two sets of registers. Now the output compare register for 8-bit timer will be also of two different types, OCRA and OCRB for timer 0 and timer 2. But for timer 16-bit timer, these are the OCR A, B, C, three compare registers for each of the 16-bit timer, and the compare value, that will be also a 16-bit compare value. So the higher byte of compare value and the lower byte of compare value will be stored in the OCR XH and OCR XL. X means X equal to 1, 2, X equal to 1, 3, 4, 5. So there are two sets of, and corresponding flag registers are stored in TIFR X for all the timers. Here X is 0 to 5. Flag register means OCF 0A, OCF 0B, OCF 0C, okay, TOV 0, TOV, all such things. Okay, flag registers. Next is the TCCR A for timer 0, timer 2, TCCR A and B. They are actually holding the bits that are required for setting the mode of the timer. The mode may be normal mode or the CTC mode. Now the P scaler will be also controlled by TCCRB. Okay, P scaler will be controlled by TCCRB register. Okay, now to stop the timer, our CS bits will be 0, 0, 0, and to start the timer, it will be any value in between 0, 0, 1 and 1, 0, 1. But for 1, 1, 0 and 1, 1, 1, these two are the counter operation. Okay, and for and the modes are also, I told you that these are the modes, and the flag can be reset by sending a logic 1 to the flag position of the TIFR. That is, so when we write a 1 to the TOV flag, that flag will be cleared to 0. Okay, so this is a peculiar thing, amazing thing, but that is happening here. That is the hardware actually specification. Next is, so same procedure is applied for timer 2 also. So timer 0 and timer 2, they are exactly the same. Only the name of the registers are different. Here 0 will be replaced by 2 throughout the name of all the names of the registers. Now I told you also that in the Arduino board, Arduino Mega 2560 board, timer 0 is occupied by an inbuilt function, Arduino related inbuilt function, delay millis and micros. Okay, timer 2 is controlled by an inbuilt function, Arduino function tone. Some of the servo libraries, if we use it at all, will be captured by timer 5 for the Mega. Okay, timer 5 and used, and in for those who are using Uno board, timer 1 will be used by the servo libraries in the Uno board. Then timer 5 will not be used, will be free. Okay, but note that whatever program I am giving it to you for the Arduino Mega 2560 board, I cannot give you guarantee that all the programs will run in the Uno board. It may run, it may not run, because the bit positions in the registers and the specification of registers in the Uno board are although mostly they are same, but in some cases there are a little bit differences present as well. So it may happen that some of the programs that I am showing you may not run in the UNO board. Okay, be aware of that thing. May not run because their specifications have some little bit changes. But I can assure you that the program that I am giving it to you, they will always run in the Mega 2560 board. Always. Okay, that I can give you the guarantee. That is the thing. Now, in our case, we'll learn how to write the program for 16-bit timer. That is timer 3, 4, and 5 also. And timer 1 will not timer 1 also, obviously. So let's see how to write the program. For timer 1 also, 3 control registers, TCCR A, B, C, and TIFR for flag registers are there. Timers will be run in normal mode and CDC mode. Now we want to see how to write the program in normal mode for the timers. Okay, so let's see. Now, first we want to set the WGM bits. WGM means waveform generation mode bits. These are the WGM 0, 1, 2, and 3. So these are the waveform generation mode bits. Yeah. So what is that? We want to run the timer in the normal mode. So all the 4 bits will be 0, 0, 0, 0, 0, 0, 0, 0, 0. That will be there. Then to set the prescaler, we have to configure CS bits 0, 1, and 2 in the timer mode. And obviously TOB flag will be 1 if we want to clear it. So first we check whether TOB bit is 1 or not. If TOB bit is 1, it means timer has attained the final count. Then we will clear the TOB flag. At the same time, we will stop the timer. We will clear the TOB flag, and at the same time, we will stop the timer. Okay, same procedure is adapted for all the 16-bit timers, timer 3, 4, and 5 as well. Okay, the corresponding registers are exactly the same. Only thing is, one will be replaced by 3, 4, and 5 respectively. For timer 3, 4, and 5. For timer in normal mode. First we choose the timer. Okay. First we choose the timer and the value of the prescaler. Then we'll choose selecting the mode of the timer using WGM bits of TCCR A and TCCR B. X means X is a number that will vary from 0, 1. Sorry, that will vary from 1, 3, 4, 5 for selecting a particular timer or the selected timer. Then we'll find out the count value TCNT to attain a particular time delay operation. You should calculate what will be the required value of TCNT.